They are the fastest, the largest, and the most dangerous in the world. They conquer every terrain, and they overcome borders.
This is a very challenging thing to bring out a new ship like this.
But it is much more than a challenge.
It's absolutely a privilege to be here and do this.
Their design goes beyond the scope of what is technically possible, setting new standards. These vehicles are milestones of engineering.
This is the father of air travel.
On land, on water, and in the air, all of them are ultimate vehicles. In this episode, Giants of the Skies, the biggest passenger aircraft in the world. When cargo is too bulky for other aircraft, this giant goes into action, the Antonov 124. A jumbo jet that flies with the hatch open, the biggest research aircraft in the world. An airplane for $70,000, an hour, the first Boeing 787 designed as a business jet. And the ancestor of all modern airplanes, the DC-3, used in the Amazon basin. It is the king of the skies, the Airbus 380, the biggest and also the heaviest passenger airplane on Earth. Its maiden flight was in April 2005. The 70-meter-long plane has space for up to 853 passengers. And with its 80-meter wingspan, it is wider than a soccer field. Germany, Frankfurt Airport. Germany's largest airport is home to Lufthansa's A380 fleet. Every 8 days, a service check is performed. Landing gear, engines, wings, empennage, and electronics are checked, just like the plane's interior. The two passenger decks are as large as two tennis courts. According to Airbus, these are the largest and most comfortable cabins around. Joachim Schwarzenberg and his two colleagues are among the airline's 370 pilots qualified to fly the A380. Their destination today, Hong Kong. They head to the airplane with the 21 members of the cabin crew. Another record. The airline puts such a large cabin crew on no other airplane.
Every time you come here, you're impressed by the size, by everything. You see all the baggage, like a whole village is about to fly through the air. More than 500 people. It's really quite special.
Joachim Schwarzenberg has been flying the A380 for 7 years. In addition to the size, it is above all the cockpit that thrills him. It is the most modern in the world.
This is a real evolution with respect to the last generation of planes. We now have an interface between the screens. We have a keyboard here, which lets us work differently. And the plane is in communication with the ground the whole time.
Errors and problems are recognized much sooner. Yet, despite state-of-the-art technology, a final exterior check before takeoff is required. Captain Joachim Schwarzenberg looks for tears in the exterior skin, for dripping lines, and checks the 22 wheels.
These are truck tires in Formula One format. They have to hit a speed of 360 and be able to handle it. So it's important that they're all okay.
While Joachim Schwarzenberg checks the last parts, 15 meters above him, the last passengers board the plane. The A380 can carry as many as 853 passengers. Lufthansa offers only 509 seats on the A380, but this is still more than on the second largest plane, the Boeing 747. Almost the entire upper deck on this A380 is reserved for first and business class. The so-called main deck is home to the cockpit, 7 galleys and over 400 economy class seats. The lower deck has places for the crew to sleep and plenty of space for luggage and extra freight. After all passengers have boarded, the 11-hour flight to Hong Kong begins.
I'm releasing the brake, and we can push back.
This is very hard work for the aircraft tractor. Fully loaded and refueled, the A380 weighs a hefty 560 tons. Then, Captain Joachim Schwarzenberg starts the 4 powerful Rolls-Royce engines.
Ready.
Stabilized. Take off.
Despite its gigantic proportions, the A380 does not need a longer runway than any other wide-bodied aircraft. After fewer than 3,000 meters, it lifts off. Toulouse, France. This is where final assembly of the A380 takes place. In only 4 weeks, this aircraft is assembled from over 4 million individual parts and over 500 kilometers of cable. Richard Carcaillier is the company's head of strategic marketing and has closely followed the airplane's development.
At the end of the 90s, air passenger volume rose so drastically that the largest plane to date, the Boeing 747, was no longer big enough. Airbus was still a very young company at the time and wanted to expand in the sector in which Boeing had had a monopoly for 30 years.
It took just about 5 years and $12 billion to design and build the first A380. The engineers were confronted with serious challenges.
State-of-the-art technology was necessary in every aspect. Aerodynamics, materials for reducing the aircraft's mass, and the engine, designed to consume 15 to 20% less fuel per seat compared to the 747.
To meet these needs, the engineers chose a form that was entirely new. In contrast to the Boeing 747, the A380 has 3 decks that stretch over the entire fuselage. This makes the airplane more streamlined and thus more aerodynamic. But the true revolutionary thing is the lightweight construction. For the first time, glare was used, a laminate composed of aluminium and glass fiber. As a result of using new materials like this, an empty A380 weighs about 15 tons less than a comparable traditional airplane. On the 27th of April 2005, it was ready. With 2 test pilots and 4 engineers on board, the first A380 took off for a 5-hour maiden voyage. In an emergency, the 6 testers could have parachuted out of an escape bay, but the flight experienced no problems. Richard Carcaillier still remembers this day well.
Working on a program like this that lasts 8 years, with an airplane for which you've developed a certain affinity, when the first flight takes place and everyone is watching and inspecting the plane, that is a special feeling. And everyone clapped.
Despite initial problems with series production, the A380 is today used by 13 airlines and is among the safest and most reliable airplanes in the world. This Lufthansa A380 has meanwhile almost reached its destination, Hong Kong. Captain Joachim Schwarzenberg and his colleagues are preparing the approach.
The A380 actually lands very nicely. We have to pay attention to the mass, of course. The mass is so great that we must do everything a bit earlier to make up for inertia.
During landing, the so-called brake-to-vacate system is used. First employed in the A380, it calculates the optimal braking distance and automatically activates the brakes at a predetermined point on the runway. The landing itself remains the job of the pilot, however.
100. 50, 40, 30, 20, retard, retard, retard.
After 11 hours in the world's biggest aircraft, the 508 passengers have reached their destination. Joachim Schwarzenberg is satisfied with his plane.
This plane was amazing. I would pet it if I could.
The crew will rest for 2 days, but in 7 hours, the A380 will take its next 508 passengers to their destination. Later in this episode, the AN-124, the biggest serially produced cargo plane in the world. Originally designed for transporting rocket launching ramps, today it is used in civil aviation. From the modern pinnacle of passenger air travel to its very beginnings, this next ultimate vehicle opened the skies to the masses. It is a legend.
The father of modern air travel.
Something from this ultimate vehicle is found in every modern airplane. The DC-3, a revolutionary plane that ushered in a new era of flying. And a good 70 years after it stopped being produced, it is still being used. The Douglas DC-3 completed its maiden flight on December 17, 1935. It is almost 20 meters long and has a wingspan of about 30 meters. More than 16,000 aircrafts of this type have been built in total. Hundreds of DC-3s are still flying in many places, but nowhere as regularly as in Villavicencio in the middle of Colombia. The small city is about 100 kilometers away from the capital, Bogota. This is where the legendary airplane takes off and lands. More precisely, at La Vanguardia Airport. From here, the DC-3 regularly flies important aid supplies to the Amazon region, just about unreachable by car. The flight lasts 1 hour. The DC-3's great advantage: it can withstand mighty gusts and very heavy rainfall. According to myth, it can even land without a pilot. Be that as it may, Germán Romero sits in the cockpit every day. As pilot, he is also responsible for the entire cargo, and today for something special too.
There's a music festival at our destination. So, we're also taking a porta potty and many instruments for the musicians.
While cargo is being loaded at the tail, technicians check the front of the aged plane and refuel it. Everything manually and more or less according to feeling. There are no electric fuel gauges. No wonder, considering the aircraft's age.
The aircraft is 81 years old. And I've logged over 20,000 flight hours with it. I've been flying it for 38 years.
No mistakes are allowed during the inspections. Germán Romero has already made it through many dicey situations with the plane, and he has faith in it precisely because of its simple design.
In my view, it is the safest aircraft by far, in all kinds of weather, with incredible performance. The father of aviation.
More DC-3s have been produced than any other passenger airplane in history. In Colombia, it is an indispensable means of transportation. To maintain the plane's balance, the crew weighs every piece of baggage by hand to determine its place in the cargo hold. Loading is complete. Germán Romero moves into his living room, the cockpit. Computer and high-tech equipment are nowhere to be found. But that doesn't bother the experienced pilot. On the contrary.
This is an aircraft that is simply fun to fly. Many people are trained on it because you have to be able to fly with this aircraft.
The runway is clear for takeoff. The 8 tons of flying metal start moving. From this point on, it's all a matter of feeling and muscle strength. There are no hydraulic systems. In flight, the DC-3 is uncommonly easy to handle. Its design lets it fly very smoothly. This is thanks to what was at the time an innovation in aircraft construction. In all pre-DC-3 models, the wings are at a right angle to the fuselage. But the plane's creators discovered that an arrow-shaped wing design shifts the center of gravity, thus improving stability. This innovation continues to be incorporated in modern airplanes. In addition, designers came up with a trick to reduce turbulence. A small curvature where the wing meets the fuselage. All this makes Germán Romero's work easier. Still, the classic plane doesn't fly itself.
Takeoff is the hardest part, but landing is the most dangerous.
Mechanics carry out daily maintenance to keep the DC-3 flying smoothly. In Colombia, this takes place not in an orderly hangar, but on the side of the runway, under a blazing 40-degree sun. All under the watchful eye of Chief Mechanic Mario Parra. Spare parts are taken from old planes that are no longer fit to fly.
It's an old plane, but it's so well designed that it can fly with only one motor. As long as we maintain it, everything is fine.
The engine technology and wing design were revolutionary. And even today, the DC-3 is considered tough, flexible, easy to operate, and easy to maintain. All the parts are welded together with 500,000 rivets. The DC-3's history begins with supply problems at the competitor, Boeing. Trans World Airline needed airplanes and asked Douglas to design an aircraft. This was the birth of the DC-3 and thus of commercial air travel. Since it needed less fuel, flying became affordable. The new airplane was also supposed to be bigger. Till then, bigger had always meant longer, but not with a DC-3. Earlier planes had a square fuselage. But this shape put limits on size. The DC-3 was designed with a round fuselage, which provided greater stability. Structural shapes still in use today. Only the electrical systems and individual parts of more recent airplanes have been improved, and thankfully so.
Most of the DC-3's problems are the same as in other planes, but one crops up frequently. When it rains a lot and the engine gets wet, then the electrical system goes haywire as the old parts get moldy very quickly.
Problems not faced anymore by mechanics dealing with modern airplanes. Nevertheless, people in Villavicencio still keep on flying the DC-3, especially due to its ability to land on non-paved runways when flying to remote Amazonas regions. Like Germán Romero does. The flight to La Macarena lasts about 1 hour. A small onboard computer gives the pilot information about altitude and GPS position. When there is room, the plane also takes passengers. Being a pilot is a dream job for many people, including Germán Romero.
I always wanted to become a pilot, even as a young boy. And now I've been in the pilot seat since I was 18. It's the best.
The approach to La Macarena Airport, especially difficult due to extreme crosswinds and heavy gusts. But Germán Romero nails this landing too. Not perfectly, but safely and skillfully.
The flight was good, but we had really strong winds while landing. It wasn't easy, actually somewhat rough. Otherwise, perfect.
Another successful deployment for the DC-3 here in Colombia's Amazon basin. The over 80-year-old classic airplane has succeeded in bringing important goods to the remote location of La Macarena. And today's load also includes the porta potty for the upcoming music festival. Outstanding loading capacity and a nose that opens. Later in this episode, the biggest serially produced cargo plane in the world, the Antonov AN-124. The DC-3 made flying a pleasure for the masses, but there are still massive status differences in the skies. This so-called dream jet is the first 787 business jet, and at the same time, one of the most luxurious business jets in the world. The Boeing 787 is the most modern commercial aircraft in the world. A business model was first unveiled in May 2016. It can fly 16,000 kilometers non-stop. This 224 square meter plane provides space for 380 people on commercial flights. The rent for the business model is $70,000 per hour. The home airport for this 787 is Haikou, on the island of Hainan in southern China. Aloof from normal air operations, the Dreamjet awaits its next assignment. With a wingspan of 53 meters, a height of 17 meters, and a length of 56 meters, it is one of the biggest business jets in the world. Jessie Mi Shanpan is the 787's cabin chief. She makes sure that its upscale passengers want for nothing.
We just received a trip request from the owner, and he wants to fly to the States, so it's going to be a long-haul operation for us. A lot of work, but we'll have to make sure the cabin's ready and it's perfect for him to fly later on.
Today, for the first time ever, a film crew is allowed to get a closer look at the exclusive luxury airplane. The first stop is the main cabin, which serves as a lounge and conference room. There is room for up to 16 people. Like normal airplane seats, the luxurious sofas and armchairs are outfitted with seatbelts and life jackets. In the back, there is place for 24 more passengers. The 18 first class and 6 business class seats are for the crew and the client's attendants. Here too, a premium was placed on appearance and luxury. The galley is located in the tail of the airplane. For safety reasons, it is a standard galley, like in every other 787-8. The lounge and the first and business class area take up most of the airplane. The tail provides just enough space for the galley. The front of the 787 contains private rooms for the main client. A bedroom as large as a whole apartment, including a king-size bed, and an adjoining luxury bathroom. Next to the bedroom, a narrow passage leads to the cockpit. Only a handful of pilots are allowed to fly this 787. In the main cabin, Jessie Mi-Shan-Pan and her team prepare everything for the upcoming flight. In less than 2 hours, the client will be there, and there is much to do.
We also need to test to see every seat working. So we were doing the testing. This is good.
All the cabin electronics, like the adjustable sofa, multimedia devices, and the lights, can be controlled from a central unit. In addition, 42 kilometers of cable were laid and 17,000 electrical connections installed. The electricity comes from alternators on the engines. The 787's engines are especially economical. Normally, hot compressed air, so-called bleed air, is taken from the airplane's engines. It is then used to maintain cabin pressure, among other things. The missing air makes combustion in the turbine less efficient. In the 787, however, this air comes from intakes in the fuselage and is then compressed electronically. The engines work more effectively and consume less fuel. Jessie Mi-Shan-Pan and her team are preparing the bedroom for the client. In addition to exquisite materials like cashmere and satin, a 42-inch television awaits the client.
This bedroom, because of the material of the wall, and you can feel it, the texture. Yeah, because of these materials, it can keep the noise down to a very low level. Even when we're flying, it is under 48 dBs.
That corresponds to the noise level in a normal apartment.
We have different light scenario for the lighting that makes our job very easy. For example, we usually keep the bedroom lighting to relax. The bedroom is basically here.
And this is where the 787 Dreamjet comes from, Everett, near Seattle, in the US. This is the home of Boeing's main plant. Charles Coburn is Director of Marketing and sees to the exclusive clients who want to buy a 787. In his view, the 787 is one of the best airplanes for a private jet.
It's the only airplane that is all composite that lets you do so much. You know, increasing the humidity so you don't have to worry about corrosion 10, 20 years down the line.
80% of the 787 is made of composite materials. The Dreamliner is about 20% lighter than an aircraft of comparable size.
Range is essential for a business jet. The 787 BBJ has the capability to fly nearly 10,000 nautical miles, which means you can go non-stop anywhere in the world that you want to.
For example, from China to the US, the route for which the Dreamjet is being prepared today. At this moment, the food for the long-haul flight is being delivered.
Sometimes they want McDonald's or Kentucky, but this time he wants catering from this hotel.
After the choice food, which must be paid for separately, is stowed in the warming cabinets, the cabin chief begins her final inspection.
Usually at the end of the check, we will have to sit on this seat because this is the seats that the principal client usually sits. When we check the cabin, we simply walk around and then we might be in different eye level. So we usually sit in here on his eye level and we might be able to pick up something wrong. It looks everything good now, finally, and we actually have not enough time today, but I think we're able to make everything perfect, and we'll wait for the client to board now.
In only 2 hours, Jessie Mi-Shan-Pan and her team have prepared the 787's 224 square meters according to the client's wishes, down to the last detail. Now, the client can come. Later in this episode, A jumbo jet filled with technology and a 20-ton telescope. Sofia, the biggest research aircraft in the world, provides images of remote galaxies. From a capricious luxury airplane to a true working horse of the skies.
It's absolutely unique. There is nothing like it.
The Antonov AN-124, the biggest serially produced transport aircraft in the world. On December the 26th, 1982, the Antonov took off for the first time. The giant's cargo hold, with a volume of 1,040 cubic meters, can load up to 150 tons. Production cost up to $80 million. Today, the AN-124 is still flying cargo around the world. The next stop, the East Midlands in Great Britain. Logistics manager Tom Blakeman is waiting here for the giant to arrive. Even for this airport employee, it is a special event every time. It weighs 400 tons and has engines as big as a car. So far, only 56 units have been produced. The Antonov is employed for exceptionally heavy transports. Tom Blakeman speaks with the flight manager.
Yeah. What time will you...
Pick up from hotel at 8 o'clock local.
Yeah.
Then at 9 o'clock we start prepare aircraft for loading.
Yeah, okay.
In the giant's belly. Here it is not the length that matters, but the height. Loads of up to 4 meters 40 centimeters fit in the cargo hold. That's a world first.
It's always an awesome sight as it's taxiing towards you. Yeah? And I think that's really the awe of it before you enter the cargo compartment. But once you enter this place, it's very much like a warehouse, a cathedral even.
For the AN-124 to be able to transport its heavy cargo, its designers had to take the engines to their limits. 4 turbines ensure that the giant reaches a maximum speed of 865 kilometers an hour.
Outsized machinery, aero engines are all designed to the maximum dimensions of that aircraft because they know that's the only way to fly it. There isn't a Western aircraft that can come close to it.
10 main landing gears, each with 2 wheels, ensure that the giant can land safely. The 2 nose landing gears have double tires and can even be retracted. For the AN-124's true highlight, cargo can be loaded in the front and in the rear. As opposed to other aircraft, the Antonov needs no ground-based aids, like loading ramps or lifting platforms. Rather, it is entirely self-sufficient. Today, the crew must also face a special challenge: quickly loading a 60-ton alternator and then transporting it to Seoul, South Korea. For the Antonov's charter flight, the client pays up to 300,000 euros.
Get going, kids. Once it's on, we're done.
Once the alternator is on the rails, 2 winches pull the €5 million cargo into the belly of the transport aircraft, all under the watchful eyes of the loadmaster, Sergei Bulachenko.
Loading finished on time, indeed 15 minutes early. So everyone's happy. It's all good. Now we're taking a break, since our work is done.
In the cargo business, lost time means above all lots of money. 4 hours after loading began, the giant's nose closes. Originally, the AN-124 was developed as a strategic military transporter for the Soviet armed forces. An advantage: thanks to the flat ramp in the nose, armored track vehicles can drive directly into the cargo hold from the ground. In addition to easy loading, the Antonov also scores with another feature. The air pressure of the tires can be adjusted in flight by a whole 30%. Thus, the transport plane can also operate on unprepared runways or on hard-packed snow. Whether on a gravel track or asphalt, the Antonov is versatile and robust. As a result, it has achieved a monopoly that endures today. About 1.5 hours before takeoff, the 6-man cockpit crew arrives at the airport. Flying the Giant requires a captain, a co-pilot, 2 flight engineers, a navigator, and a radio operator. Evgen Bashinsky is finishing his training as an Antonov pilot. For the 32-year-old Ukrainian, the cargo plane is one of the most thrilling aircraft of our time.
Computers make his job in modern aircraft. But here we should have a radio, navigator, flight engineer who control all the instruments and systems of this aircraft.
The airplane was designed in the late 1970s. Thus, every instrument must be operated and checked by hand. But for Evgen Bashinsky, this is not the Antonov's biggest challenge.
One thing makes this aircraft harder to control, harder to operate. Not each airport can provide enough clearance for us.
Behind the cockpit, there are quiet rooms for the crew. The crew travels with the AN-124 around the world for up to 3 months.
In this chamber, we have a small kitchen.
No routine emerges. Every assignment is unique.
You never get over familiar with this airplane because every time it comes in, you always learn something new about its capabilities.
After 7 hours, the Giant takes off again. The next destination, Korea. The Antonov AN-124, truly an ultimate vehicle. The next ultimate vehicle transports the same heavy cargo every night, a 20-ton telescope. This is no normal airplane, but rather the biggest airborne observatory in the world, in the hull of a Boeing 747.
It's absolutely a privilege to be here and do this.
There's only one Sofia in the world. There's no replacement.
Sofia is an acronym for Stratospheric Observatory for Infrared Astronomy. Its objective: to study star-forming regions, planets, comets, and interstellar medium on the basis of the infrared rays they radiate. The Flying Observatory has been in use since May 2010. The cost of development and retrofitting, $1 billion. Sofia is actually a short version of the Boeing 747. It has a range of about 10,460 kilometers and can reach a maximum altitude of about 14 kilometers. Sofia's base is in the US, at NASA's Neil Armstrong Flight Research Center in California, on the edge of the Mojave Desert. Until the maiden flight of the A380, the 747 was the biggest passenger aircraft in the world. The raised nose and the bulging cockpit make the jumbo jet one of the few airplanes whose silhouette is immediately recognizable. Sofia is a project of NASA and the German Aerospace Center. Engineer Oliver Zeiler checks the core element before every mission, the infrared telescope. He does this in the command central, the former passenger cabin. The tail contains the telescope's mechanical system. which compensates for the plane's movements.
It's very different from flying with a normal plane. If something goes wrong on board with the telescope, you feel a little pressure and some tingling trying to fix it as fast as possible, but it's fun.
All right, welcome to Flight 391. Takeoff at 2028.
The weather is always important, as it influences the telescope's accuracy during the flight.
Two areas of issue right now, the British Columbia, almost all entire British Columbia. A lot of turbulence been reported today.
If it is too strong, the telescope stops working. Shortly before takeoff, flight engineer Moose Pier performs his final check.
Pre-flight inspection, we just basically make sure the aircraft's ready for flight. No panels missing, tires are in good condition. When maintenance turns the aircraft over to ops, we take responsibility for that.
40 minutes before takeoff, the pilot, scientists and engineers are on board. Now for something everyone is familiar with before a flight, the safety instructions. In the meantime, Moose Pier and the pilots prepare the 747 for takeoff.
Are you guys ready for start down there?
Ready for engine start.
Thank you.
This is pilot. You guys ready to start down there?
We're ready for you to start wherever you are.
Okay, we'll start 2 and 3.
As opposed to a standard passenger aircraft, Sofia takes an extremely long starting run. The idea is to go easy on the fragile devices on board, especially the 17-ton telescope in the tail. After takeoff, the pilots give steady full thrust to gain altitude as fast as possible. The goal? To maximize observation time for the scientists. Tonight, they plan to examine the composition of the atmosphere of various stars. Missions like this take place exclusively at night. The telescope cannot be used during the day.
This mirror has a diameter of 2.5 meters, a parabolic mirror. When sunlight hits it, it naturally focuses the light on a point. And this point, in the posterior cavity where the telescope is, gets very, very hot. It can reach several hundred up to 1,000 degrees. And that would be dangerous for the plane.
In addition to flying at night, altitude is also crucial for studying the universe.
We do operate them higher than most airlines would like to. And the whole reason for that is the higher you get, the less atmospheric moisture. Moisture is one of the things that obscure the science observation. So the higher you get, less moisture equals better science.
The aircraft reaches an altitude of 10,700 meters, perfect for opening the door to the telescope.
It should be moving. Door moving.
And now, the unbelievable happens. A huge hole opens on the side of the 747. Every passenger's nightmare. But this time, it's on purpose, and at a speed of about 1,000 kilometers per hour.
When the door opens, you don't hear it or feel it. The pilots don't feel it in the airplane's trim. You don't really even notice it at all.
There's a fairing back there that creates the airflow to not get in the telescope assembly, so it's a pretty brilliant design.
With the door open, air should rush into the airplane. The result? Increased fuel consumption and air vibrations that would disrupt the telescope's aligning accuracy, and over time, damage the airframe. This is avoided thanks to a sophisticated covering in front of and behind the door. It leads the air current away from the telescope. To keep the plane steerable, behind the opening, the air slides along the plane to the empennage. In this way, Sofia can fly steady even with a huge hole in its side. Sofia is at the forefront of technology. It was designed and built over a period of 20 years. Today, project leader Eddie Zavala is in charge of this unique plane.
When you first see Sofia, many people tell me that their first reaction is, wow, this is a big airplane. And it truly is. It is the world's largest airborne observatory.
Sofia's basic frame is a modified Boeing 747. The idea was to combine the biggest airplane of the day with the biggest possible infrared telescope. The aircraft was disassembled into 3 pieces and then put back together by the same company that builds Air Force One for the American president.
There were a lot of engineering challenges, primarily, first of all, putting a 17 metric ton telescope with a 2.5 meter primary mirror in the back part of the airplane with a door that opens up without causing aeroacoustic resonance. If we had had acoustic resonance when we opened the door, Sofia would sound like a train whistle as the airplane is flying at 500 knots.
Another challenge. The big telescope makes the airplane tail heavy. Thus, a counterweight is provided by tungsten plates under the cockpit. The scientists are observing objects in the night sky that are light years away. The telescope always maintains the same position, compensating for the airplane's movements and turbulence.
Right now, as you feel this little light turbulence, this little chop, the telescope assembly is stabilized, and it's kind of like a rigid in space. It's almost like a flying gyro.
But today, the telescope is taken to its limits. The turbulence is too strong, and the telescope no longer responds to computer commands. A mad rush at mission control on board. The problem is quickly found. There's no electricity.
What are you proposing for a solution here? Just want to take everything down and show results later. All right, so we've got one shot to reboot that, to reset that's the circuit, right?
Rebooting the system, a big problem, a simple solution, but not simple for a priceless plane while still in the air.
There's a mission rule on board. When a circuit breaker trips, you can reset it once and continue. But if it trips again, then it is clear that there is a problem somewhere in the device, and then you can't keep trying to reset it 2 or 3 times. And you either have to keep this system turned off, or the mission is over.
A catastrophe for the scientists. They often work on their research for years and have only this one moment to test their theories. Thus, Oliver Zeiler and the engineers on board must resolve the problem as fast as possible.
Now I feel better. We resolved everything and the scientists are happy again. We're observing again, collecting data. Yes, now it's working again.
The telescope and the computer are working again, according to plan. The mission has been salvaged and much money saved. The flight's kerosene alone costs 80,000 euros. Oliver Zeiler and his engineering team make sure that the telescope performs dependably. The airplane itself is constantly being checked by Moose Pier. It fascinates the flight engineer as much as it did on his first day.
It was kind of overwhelming that, you know, you can take something that is such a modification and actually get it airborne. And you think about all the coordination and the teamwork that takes place to make every mission work is fascinating every time you fly.
Sofia's research missions are planned until 2030. What happens after that is unclear. Until then, the 747 operated by NASA and the German Aerospace Center remains the only and the biggest airborne observatory in the world, and a true ultimate vehicle.